Hello, I'm Max Tansky, and today I'll be showing you how to do integration by trigonometric substitution. Okay, so the first thing you want to do is look at your problem, decide if it fits any integration rules that we know, and it kind of looks like it would be an arc sine, but it's not because for arc sine to work, it had to be 3 minus t squared, and it's 3 plus t squared. So that won't work here. And no other rules really fit it, so that means we're going to have to use a different route to solve this problem. And the only other route that would work would be trigonometric substitution. So for trigonometric substitution, you need to have in your equation one of these forms. For a sine substitution, you're going to need root a squared minus x squared. For the tangent substitution, you're going to need root a squared plus x squared. And for the secant substitution, you're going to need x squared minus a squared. Root x squared minus a squared. So, as we can see, it would fit the tangent substitution. So we're going to draw a triangle. Label this part as our hypotenuse. And the components that make this up, we're going to put those as our legs. Because in the Pythagorean theorem, it would be a squared plus b squared. Root a squared plus b squared will get you the hypotenuse. So we're going to have root 3 plus the t right here. Okay, and now the trigonometric substitution for tangent states that t is going to equal root, or just regular a times tangent theta. And this is where we draw our theta from. Okay, so what we know from that is we can start plugging in what we know from the triangle. So t equals root 3 tangent theta. And now, of course, to substitute this t in, we're going to need to solve for dt as well. So we take the derivative of this, find that dt equals root 3 secant squared theta. Now, what you could do is just plug the t in, plug the dt in, try to simplify it and integrate it. But in order to make this problem easier, we're going to solve for this in this equation. So we know that secant of theta would equal hypotenuse over adjacent. So it would be root 3 plus t squared all over root 3. And now since we just want to substitute this in for something, we're going to solve for it in this equation. So we'll find that root 3 plus t squared is indeed equal to root 3 secant theta. Okay, from there we can start just plugging in things, plugging in to make this problem look a bit easier. So we're going to take this, just plug it straight in. So we're going to find that the integral, we're going to put the dt in first on top. So root 3 secant squared theta over root 3 secant theta, d theta. Because once you derive it, you're going to need a d theta, so it's in terms of theta, respect to theta. Okay. So you start simplifying, simplify the secant, and you're going to find that this is just going to equal the integral secant of theta d theta. Now that fits one of our rules. It's just going to be straight trigonometric, or a straight integration rule, and we find that that equals just the natural log of tangent theta plus secant theta plus a constant. Okay, that looks good, but it's not completely done yet because we started off in terms of t, so we need to end in terms of t. We can't keep it in terms of theta. So what we're going to do here, in order to put it back in terms of t, is we're going to solve for theta from what we know up here, from this equation and this equation. So the first time we solve for theta, it's going to be the same theta, it's just going to be in different terms. It's going to be in terms of tangent, it's going to be in terms of secant. So we solve for theta from this equation. We divide this over. So t equals root 3 tangent theta. Solve for it, divide the root 3 over, take the tangent inverse. We're going to find that theta equals the tangent inverse of t over root 3. Do the same thing right here. Write it out. 3 plus t squared, root 3 plus t squared, equals root 3 secant theta. Now we divide that over, take the secant inverse, find theta. Theta is going to be the secant inverse of 3 plus t squared all rooted, all over root 3. Plug your thetas into here. We're going to plug this one into the secant, so the secant and the secant inverse cancel out, and the tangent inverse cancel out, so it'll look like this. Natural log of tangent of the tangent inverse of t over root 3 plus the secant of the secant inverse of 3 plus t squared all rooted, all over root 3, plus c. Okay, we simplify this up. The tangents cancel out and the secants cancel out. And then I'm going to flip this over real quick. And we're going to find that the natural log of t over root 3 plus root 3 plus t squared over root 3 plus a constant. Okay, that looks okay. You can combine the denominator here so it looks a bit nicer. And most professors probably would accept that, but some might want to take it a bit further. So we know that this is a identity for a hyperbolic function, an inverse hyperbolic function. And it just so happens to be the sine inverse hyperbolic function. So you just take this part right here, and this part would equal the inverse hyperbolic sine of t over root 3 plus c. And there, folks, would be your answer.